Right, this is number 4 from the last minute review worksheet. Let me read the problem here. Watermelons are beginning to come in season, and a warehouse is receiving the watermelons over time. The strictly increasing in twice differentiable function just means it's a smooth curve. W models the total amount of watermelons in the warehouse with t greater than or equal to 0 weeks. It is thought that the function w will satisfy the differential equation of dw dt equals 2t times w minus 9, where w is measured in number of watermelons and t is measured in weeks. At t equals 2 weeks, there are 10 watermelons in the warehouse. So part A says write an equation to the line tangent to the graph of w at t equals 2. Use your tangent line equation to approximate the amount of watermelon in the warehouse at t equals 3 weeks. So if we want to find the equation of tangent line, we need to find order pair and slope. So order pair is t being our independent variable, w is our dependent. So at t equals 2 weeks, there's 10 watermelons. We want to figure out the rate of change at this moment in time. So we have dw dt, which acts as our derivative equation. Plug 2 in for t, 10 in for w, and we get 2 times 2 times 10 minus 9, which is 4. We're going to write our tangent line equation, but instead of x's and y's, I'm going to use w's and t's. So w minus 10 is equal to m, which is 4, times t minus 2. Solve for w, add 10 to both sides, and now we have our linear equation. We're going to use this to approximate how much is at the warehouse in 3 weeks. So plug 3 in for t. We get 4 times 1 plus 10, which is 14. So approximately 14 watermelons at 3 weeks. Part B, find the second derivative, d2w over dt2. Use the second derivative to determine whether your approximation from part A is an overestimate or an underestimate of the amount of watermelons in the warehouse at t equals 3 weeks. So we need to find the derivative of our dw dt in order to move to the second derivative. Now, we have to keep in mind that I know we're seeing some strange variables here. We're used to seeing something maybe in terms of x and y. So treat t like you would x and treat w like you would y's. And imagine you're trying to find the derivative that is 2x times y minus 9. Okay, 2x times y minus 9. We know we have to go through product rule because we have 2 separate variables. So we do f prime g plus f g prime. Now, just like with implicit differentiation with x's and y's, when we find the derivative of x, we don't do anything additional with it, right? We just find the derivative and then that's the end of it. But when we find the derivative involving y's, we have to attach a dy over dx. So much the same way, here we have to attach dw dt because t is the independent variable, so everything is with respect to t. Just like if it was x's and y's, 2x would become 2, and then y will become dy dx. So much the same way, w is going to become dw dt. Okay, so we have to go through product rule, f prime g plus f g prime. 2t becomes 2, g stays the same, back to f stays the same, and then now w minus 9, the derivative of w is 1 dw dt, and then 9 goes away to 0. Okay, we have our second derivative expressed. Now we're going to find, we're going to have to plug in t and w to figure out the second derivative value. It says use the estimate from part A. So we found that our at t equals 3 weeks, there's 14 watermelons. So we can plug 3 in for t and 14 in for w. When we do that, we get 2 times 14 minus 9 plus 2 times 3 times dw dt. Now dw dt, we're going to have to find this value. So we have to use dw dt, plug 3 and 14 into our dw dt equation. So we get 2 times 3, 14 minus 9, and that gives us 30. So dw dt at this moment in time is 30. So multiply all that together, we get 2 times 5, which is 10, plus 6 times 30, which is 180, and we get 190. Now 190 with the second derivative value, that indicates that if we're dealing with a positive second derivative value, we must be dealing with a concave up graph. So the concave up graph, our linear approximation, a line that is tangent to a curve that is opening up is always going to be is always going to sit below the curve. So we know that our tangent line is going to be an underestimate of the actual value because we know our curve is part of a concave up graph. All right, part F, find the particular solution to w of t using the differential equation that was given to us at the beginning of the problem. So we know we have to go through separation of variables. We want to group all the w's on the left side, all the t's on the right side. So I'm going to go ahead and multiply dt over to the right side. Let's just get everything up in the numerator, and then let's see if there's anything that's out of place. So the only thing that we see out of place is this w minus 9. We'll divide that w minus 9 over. Now we have w's on the left, t's on the right. Let's take the indefinite integral on both sides. All right, so this side requires u substitution. We have to let u value be w minus 9. Derivative of u with respect to w is 1. So dw equals du. We make our substitution. We get du over u, or 1 over u du. So we find the antiderivative. This becomes natural log of absolute value of u. 2t becomes 2t squared over 2 plus c. Replace the u back in terms of the original variable, and now we have our antiderivative. Let's go ahead and find c. We know our order pair that we're going to plug in to find c is 2, 10. 2 in for t, 10 in for w. So we get 10 minus 9, which is 1. 2's cancel out. We get 2 squared, which is 4. So 0 minus 4 equals c. c equals negative 4. And now we can replace our c value with negative 4. The next step is to try to just get w by itself. Okay. What we can do is we can get this w away from the natural log expression, raise both sides, base e. Left side cancels out. We get absolute value w minus 9 is equal to e to the t squared minus 4. When we drop the absolute value, we get plus or minus. But the order pair is going to be 2, 10. So the only way we can get 2 in for t and get a positive 10 as a result is if we get to choose this to be a positive e. All right, so anytime you're dealing with a plus or minus at the end, go ahead and plug in the order pair, and usually what happens is you look at the y value. Whatever the y value is, whatever the sign of the y value is, that's going to dictate which one you choose between plus or minus. All right, part G. For the particular solution that we found, evaluate w of 0. So we're going to just find w of 0, plug 0 in for t, and explain the meaning. So the t 0 represents t in weeks. So that means in 0 weeks, how many watermelons are there? So if we plug 0 in for t, we get e to the 0 minus 4, which is e to the negative 4, which is 1 over e to the 4th. So we can say this is equal to 1 over e to the 4th plus 9. And that's going to be a really, really small decimal value. So that's like 9.001. And so we know that this is going to round to be around 9 watermelons at the warehouse when t is equal to 0 weeks, or at 0 weeks.